There is no national electrical code requirement mandating the installation of ground rods at each light pole when an equipment grounding conductor, abbreviated EGC, is present. Bonding the EGC to the pole is generally sufficient for safety and code compliance. To elaborate, let's delve into the relevant sections of the National Electrical Code, specifically Article 250, which governs grounding and bonding. The primary purpose of grounding and bonding is to create a low impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. This ensures that in the event of a ground fault, the faulty circuit is quickly de-energized, minimizing the risk of electrical shock or fire. In the context of light pole installations, the equipment grounding conductor plays a crucial role in providing this low impedance path. The IC, typically a copper or aluminum wire, is run along with the circuit conductors, that is, the hot and neutral wires, to each light pole. It is then connected to the metal enclosure of the light fixture and the metal pole itself, effectively bonding these metal parts together. This bonding ensures that if a fault occurs within the light fixture, such as a wire coming into contact with the metal enclosure, the fault current will flow through the EGC back to the source. This high fault current will then trip the circuit breaker or blow the fuse, interrupting the power supply to the faulty circuit. The code stipulates that the impedance of the fault current path must be low enough to allow for the prompt operation of the overcurrent protective device. This is why proper sizing of the EGC is critical, as a conductor that is too small may not be able to carry the fault current effectively, potentially delaying the operation of the protective device and increasing the risk of electrical hazards. Now let's address the question of whether a ground rod is required at each light pole. A ground rod, typically an 8-foot-long copper or copper-clad steel rod, is driven into the earth and connected to the electrical system. The purpose of a ground rod is to provide a connection to the earth, which serves as a reference point for voltage stabilization and helps to dissipate static electricity and transient voltages. While ground rods are commonly used in electrical systems, particularly at service entrances, they are not always required at individual pieces of equipment such as light poles. The National Electrical Code provides specific rules for when ground rods are required, and these rules are generally based on the type of electrical system, the voltage levels involved, and the presence of other grounding and bonding measures. In the case of light pole installations with an EGC present, the code typically does not require a ground rod at each pole. The EGC provides the primary path for fault current, and when properly sized and installed, it is sufficient to ensure the safe operation of the electrical system. However, there may be certain situations where a ground rod is recommended or required, even with an EGC. For example, if the light poles are located in an area with poor soil conductivity, such as sandy or rocky soil, a ground rod may be necessary to supplement the grounding provided by the EGC. Poor soil conductivity can increase the impedance of the ground path, potentially hindering the flow of fault current. In such cases, a ground rod can provide an additional path to ground, helping to lower the overall impedance and improve the effectiveness of the grounding system. Another situation where a ground rod may be required is when the light poles are part of a separately derived system. A separately derived system is an electrical system that receives its power from a source other than the main utility service, such as a generator or transformer. The National Electrical Code has specific requirements for grounding separately derived systems, and these requirements often include the installation of a ground rod at the source of the system. If the light poles are fed from a separately derived system, it is important to consult the code to determine whether a ground rod is required. It is also important to note that local codes and regulations may have additional requirements for grounding light pole installations. Local codes may be more stringent than the National Electrical Code, and they may require ground rods at each pole regardless of the presence of an EGC. Therefore, it is always advisable to check with the local electrical inspector to ensure compliance with all applicable codes and regulations. In summary, while the National Electrical Code generally does not require ground rods at each light pole when an EGC is present, there may be certain situations where they are recommended or required. These situations include areas with poor soil conductivity, separately derived systems, and local code requirements. Always consult the code and the local electrical inspector to determine the specific grounding requirements for your light pole installation. Now let's discuss some best practices for bonding the EGC to the light pole. Proper bonding is essential to ensure that the metal parts of the light pole are effectively grounded and that a low impedance path is provided for fault current. The National Electrical Code specifies the methods and materials that should be used for bonding, and it is important to follow these guidelines to ensure a safe and reliable installation. One common method of bonding is to use a bonding jumper, which is a short length of copper wire that connects the EGC to the metal enclosure of the light fixture and the metal pole itself. The bonding jumper should be sized according to the requirements of the National Electrical Code, and it should be securely fastened to the metal parts using approved connectors. Another method of bonding is to use a bonding bushing, which is a special type of fitting that is installed on the conduit that enters the light pole. The bonding bushing has a lock that is connected to the EGC, providing a direct connection to the metal conduit and the light pole. Bonding bushings are particularly useful when the conduit is made of metal, as they help to ensure that the conduit is also effectively grounded. When bonding the EGC to the light pole, it is important to remove any paint or corrosion from the metal surfaces to ensure a good electrical connection. Paint and corrosion can increase the impedance of the connection, potentially hindering the flow of fault current. Use a wire brush or sandpaper to clean the metal surfaces before making the connection. It is also important to protect the bonding connection from moisture and corrosion. Moisture and corrosion can degrade the connection over time, increasing its impedance and potentially compromising the effectiveness of the grounding system. Apply a corrosion inhibitor to the connection after it is made to help protect it from the elements. In addition to bonding the EGC to the light pole, it is also important to ensure that the light fixture itself is properly grounded. The light fixture should have a grounding terminal that is connected to the EGC. This ensures that the metal parts of the light fixture are also effectively grounded, providing an additional layer of protection against electrical shock. When installing the light fixture, make sure that the grounding terminal is securely connected to the EGC and that the connection is protected from moisture and corrosion. Finally, it is important to inspect the grounding and bonding system regularly to ensure that it is in good condition. Check the connections for looseness or corrosion, and make sure that the EGC is properly sized and installed. If you find any problems, correct them immediately to maintain the safety and reliability of the electrical system. In conclusion, grounding and bonding are essential aspects of light pole installations. While the National Electrical Code generally does not require ground rods at each pole when an EGC is present, proper bonding of the EGC to the pole is crucial to ensure the safe operation of the electrical system. Follow the guidelines of the National Electrical Code and local codes, and always consult with a qualified electrician to ensure that your light pole installation is properly grounded and bonded. Let's now shift the focus to metal halide, abbreviated MH, pole lights operating at 208 volts, and discuss some of the specific considerations for these types of installations. Metal halide lamps are a type of high-intensity discharge, abbreviated HID, lamp that produces light by passing an electric arc through a mixture of metal halides and mercury vapor. They are known for their high efficiency, long lifespan, and good color rendering properties, making them a popular choice for outdoor lighting applications such as streetlights, parking lot lights, and sports field lights. However, metal halide lamps also have some unique characteristics that must be taken into account when designing and installing electrical systems for them. One important consideration is the starting characteristics of metal halide lamps. Unlike incandescent lamps, which light up instantly when power is applied, metal halide lamps require a warm-up period before they reach their full brightness. During this warm-up period, the lamp's voltage and current can fluctuate significantly, which can put stress on the electrical system. To address this issue, metal halide lamps typically require a special ballast that is designed to provide the correct starting voltage and current. The ballast also helps to regulate the lamp's voltage and current during normal operation, ensuring that the lamp operates efficiently and reliably. When selecting a ballast for a metal halide lamp, it is important to choose one that is specifically designed for that type of lamp. Different types of metal halide lamps have different voltage and current requirements, and using the wrong ballast can damage the lamp or reduce its lifespan. It is also important to choose a ballast that is compatible with the voltage of the electrical system. Metal halide ballasts are available in a variety of voltages, including 120 volts, 208 volts, 240 volts, 277 volts, and 480 volt. In the case of a 208 volt system, a 208 volt ballast should be used. Another important consideration for metal halide lamp installations is the lamp's operating temperature. Metal halide lamps generate a significant amount of heat during operation, and this heat can affect the lamp's performance and lifespan. To prevent overheating, metal halide lamps must be installed in fixtures that are designed to dissipate heat effectively. The fixture should have adequate ventilation to allow air to circulate around the lamp, and it should be made of materials that can withstand high temperatures. It is also important to avoid installing metal halide lamps in enclosed spaces where heat can build up. In addition to the lamp's operating temperature, it is also important to consider the ambient temperature of the environment where the lamp is installed. Metal halide lamps are sensitive to temperature changes, and their performance can be affected by extreme temperatures. In cold environments, the lamp may take longer to warm up and may not reach its full brightness. In hot environments, the lamp may overheat and fail prematurely. To mitigate these effects, it is important to choose a metal halide lamp that is suitable for the ambient temperature of the environment where it will be installed. Metal halide lamps are available in a variety of temperature ratings, and the appropriate rating should be selected based on the expected temperature range. Another consideration for metal halide lamp installations is the lamp's end-of-life characteristics. As metal halide lamps age, their light output gradually decreases, and their color rendering properties may change. Eventually, the lamp will reach the end of its lifespan and will need to be replaced. When a metal halide lamp reaches the end of its life, it may exhibit a phenomenon known as cycling. Cycling occurs when the lamp repeatedly turns on and off, often with a flickering or pulsating effect. This is caused by the lamp's ability to maintain a stable arc, and it is a sign that the lamp needs to be replaced. In some cases, a metal halide lamp may fail catastrophically, shattering or exploding. This can be caused by a variety of factors, including overheating, voltage surges, or manufacturing defects. To prevent catastrophic lamp failures, it is important to inspect metal halide lamps regularly for signs of damage or wear, and to replace them promptly when they reach the end of their lifespan. It is also important to use surge protection devices to protect the lamps from voltage surges. Now let's discuss some specific considerations for 25-foot steel poles. Steel poles are a common choice for outdoor lighting applications due to their strength, durability, and resistance to corrosion. However, steel poles also have some unique characteristics that must be taken into account when installing electrical systems on them. One important consideration is the grounding of the steel pole. As we discussed earlier, the metal parts of the light pole must be effectively grounded to ensure the safe operation of the electrical system. In the case of a steel pole, the pole itself can serve as the equipment grounding conductor, provided that it is properly bonded to the electrical system. To bond the steel pole to the electrical system, a grounding electrode conductor should be connected to the pole using an approved connector. The grounding electrode conductor should be sized according to the requirements of the National Electrical Code, and it should be connected to a grounding electrode system such as a ground rod or a metal water pipe. It is also important to ensure that the steel pole is protected from corrosion. Steel is susceptible to corrosion, especially in outdoor environments, and corrosion can weaken the pole and compromise its structural integrity. To protect the steel pole from corrosion, it should be coated with a corrosion-resistant material, such as paint or galvanizing. The coating should be applied to all surfaces of the pole, including the interior and exterior. In addition to coating the steel pole, it is also important to inspect it regularly for signs of corrosion. Look for rust, peeling paint, or other signs of damage. If you find any corrosion, repair it promptly to prevent further damage. Another consideration for steel pole installations is the wind loading. Steel poles are subject to wind loads, which can put stress on the pole and the electrical system. The wind load on a pole depends on a variety of factors, including the height of the pole, the size and shape of the luminaire, and the wind speed in the area. It is important to select a steel pole that is strong enough to withstand the expected wind loads. The pole manufacturer can provide information on the pole's wind load rating. In addition to selecting a pole with an adequate wind load rating, it is also important to properly install the pole. The pole should be securely anchored to the ground using a concrete foundation or other approved method. The foundation should be designed to withstand the expected wind loads, and it should be installed according to the manufacturer's instructions. It is also important to consider the weight of the luminaire when installing a steel pole. The luminaire can add significant weight to the pole, especially if it is a large or heavy fixture. The pole should be strong enough to support the weight of the luminaire, and the foundation should be designed to withstand the additional load. The pole manufacturer can provide information on the pole's weight capacity. Finally, it is important to maintain the steel pole regularly to ensure its long-term performance. Inspect the pole for signs of damage, such as cracks, dents, or corrosion. Repair any damage promptly to prevent further deterioration. It is also important to keep the pole clean and free of debris. Debris can accumulate in the pole and trap moisture, which can accelerate corrosion. In summary, metal halide pole lights operating at 208 volts have some specific considerations that must be taken into account when designing and installing electrical systems for them. These considerations include the lamp's starting characteristics, operating temperature, end-of-life characteristics, and the grounding and corrosion protection of the steel pole. By following the guidelines of the National Electrical Code and local codes, and by working with a qualified electrician, you can ensure that your metal halide pole light installation is safe, reliable, and long-lasting. Always remember that safety is paramount when working with electrical systems. If you are not comfortable working with electricity, or if you are unsure about any aspect of the installation, consult with a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical shock.